Carboxylic acids are organic compounds which have a carboxyl C double bond O OH functional group. The general formula for carboxylic acid is RCOOH or RCO2H, where R it can be an alkyl group, aryl group, or hydrogen. The rules used to name the carboxylic acid are similar to other organic compounds. The longest continuous carbon chain, which is our parent chain, must contain the carboxyl group. Then, number the parent chain starting with the carboxyl carbon atom. The carboxyl carbon atom is numbered as carbon 1, but we are going to omit this number from the name. Next, if we have any substituent present, give the position of the substituents along the chain. The suffix oic acid is used to replace the letter E in alkene parent name. The first 6 aliphatic carboxylic acids are well known by their common name. If we have only one carbon, alright, so the IUPAC name will become methanoic acid and the common name is formic acid. For 2 carbon of carboxylic acid, the IUPAC name is ethanoic acid and the common name is acetic acid. 3 carbon, we have propanoic acid, the common name is propionic acid. For the 4 carbon, butanoic acid and the common name is butyric acid. 5 carbon, we have a pentanoic acid and the common name is valeric acid. And 6 carbon of carboxylic acid, we have hexanoic acid and the common name is caproic acid. Let's do some example. Okay, so first we are going to find the longest carbon chain. Okay, the longest carbon chain must include the carboxyl group. So the carboxyl group here, right? So this carbon will become our carbon number 1. Okay, and then we have 2, 3, 4, and 5. Okay, so since we have 2 substituents along the carbon chain, okay, which is CH3 group, a methyl. Okay, so this one is a methyl. Okay, so the name, the IUPAC name for this compound is 3,4, okay, dimethyl, because we have 2 methyl group attached to the 3rd and 4th carbon. Okay, and then since the longest carbon chain is 5, okay, so pentanoic acid. Okay, because this is a carboxyl group. Okay, so remember the carboxyl group will become our first carbon. Alright, so the acid here, okay, we are going to separate the word acid from its name. Okay, kan selalunya alfabet dengan alfabet kita kena rapatkan, but then in carboxylic acid case, okay, acid ni kita jauhkan dia, kita separatekan dia. For the second structure, okay, so this is going to be our longest carbon continuous chain. Okay, so the carboxyl group here will become our first carbon, second, third, fourth, and fifth. Okay, so along the carbon continuous chain kita, the longest carbon continuous chain kita, we have 2 different substituents. Okay, Br will become bromo, CH3, which is the methyl group. Right, so as a single word, the IUPAC name for this compound will be 4-bromo 3-methyl pentanoic acid. Okay, 4-bromo, since B come first before M, okay, nak tulis in a single word, kita kena ikut alphabetically order lah. Okay, so since bromine duduk dekat carbon number 4, so 4-bromo, methyl on the third carbon, 3-methyl. Okay, longest carbon chain 5, so pentanoic acid. If there are 2 carboxyl group present, the compound will be named as alkane dioic acid. For example, okay, so for the first structure here, so this is our longest continuous carbon chain. So both the carboxyl group must be included in our longest continuous carbon chain. Okay, so since we don't have any other substituent here, okay, so this carbon can become our first carbon, this carbon also can become our first carbon. So it's up to you whether you want to number it from left to right or right to left. So let's say if I number it from left to right, okay, 1, 2, 3, 4, 5, okay, so the name of this compound will be pentane dioic acid. Okay, pen because the longest carbon chain is 5. Okay, dioic because we have 2 carboxy group, and then we don't need to no need to number the position of the carboxy because in an open chain, okay, aliphatic open chain carboxylic acid, the carboxy group must be placed on the terminal carbon. So kedudukan dia mesti dekat hujung ni. So kita tak perlulah kita nak nomborkan dia. Okay, position dekat mana. So pentane dioic acid, so kita tahu position of the carboxy group is on the first and the fifth carbon. Okay. For the second structure, okay, so we have the carboxy group, okay, on this carbon and this carbon. So this is our longest carbon chain, okay. So both carboxy group must included in our longest carbon chain, okay. So to number our carbon, okay, parent chain here, okay, so this carbon can become our first carbon, this carbon also can become our first carbon, but since we have a carbon-carbon double bond on the middle, okay, kita ada carbon-carbon double bond ni, so we have to give our carbon-carbon double bond also the lowest number. So if we number it from left to right, okay, the carbon-carbon double bond will falls on the third carbon, from right to left also it will falls on the third carbon, so tak kisahlah kan. So let's say I'll number it like this, okay. So 4, 5, 6. Alright. So since this is a carbon-carbon double bond, and then this carbon is attached to 2 different group, this one also attached to 2 different group. So it is a cis or trans isomer. Okay. So since the hydrogen here, okay, dia bersilang macam ni, so it is a trans isomer. So the name of this compound will be trans, okay, because it is a trans isomer, trihexene, okay, because the carbon-carbon double bond falls on the third and fourth carbon, okay, so kita ambil apa yang rendah lah, trihexene, okay, dioic acid because we have 2 carboxy group, okay, on the terminal carbon. If we have a carboxy group directly attached to the benzene ring, it will become an aromatic carboxylic acid. So the parent name for aromatic carboxylic acid is benzoic acid. We had learned this in chapter 6. Alright, so actually the IUPAC name for the benzoic acid is benzene carboxylic acid. But usually we just use the benzoic acid because it is much easier. Alright, so the carbon, okay, that is attached to the carboxy group will become the first carbon, and then we have to give our net substituent the lowest number. But since if you number it clockwise or anti-clockwise, you still will get the position of Cl falls on the fourth carbon, so tak kisahlah, it doesn't matter. So let's say if we number it like this, 3, 4, 5, 6, okay, so the name for this compound will be 4-chlorobenzoic acid because the position of the chlorine is on the fourth carbon, okay, and then the common name for the carboxy group that attached to the benzene ring is a benzoic acid, okay. Since there's only 2 substituents on the benzene ring, okay, this is a disubstituted benzene, alright, so we can use the prefix auto meta para, alright. So since in this case the position of the substituents falls on the first and the fourth carbon, so we can also name this compound as para-chlorobenzoic acid. But if there are 2 carboxy group present on the benzene ring, okay, so we call it as an aromatic dicarboxylic acid. It is named as 1, okay, so because one of the carboxy group, okay, the carbon that attached to the carboxy group can become the first carbon, and then X is the position of another carboxy group, benzene dicarboxylic acid. So for this structure, so since there's no other substituent except for the carboxy group, okay, so this one can become our first carbon, this one also can become our first carbon. So 1, 2, 3, give the second carboxy group the lowest number, 4, 5, 6, okay. So the IUPAC name for this compound is 1,3-benzene dicarboxylic acid. For a cyclic carboxylic acid, okay, the cyclic carboxylic acid is named as cycloalkane carboxylic acid, where the carbon atom that is attached to the carboxy group is numbered as carbon number 1. Okay, so let's say we have 5 carbon here, our cyclic compound. The carbon that is attached to the carboxy group is numbered as carbon number 1. So since we have 5 carbon of our cyclic compound here, so it will become cyclopentane carboxylic acid. For the next structure, on our cycloalkyl, we have more than one substituent. Okay, so remember the carbon that is attached to the carboxyl group will become the first carbon and then give the next substituent the lowest number. So since here we have CH3 group on the next carbon, so it will become carbon number 2, 3, 4, 5, 6. So the IUPAC name for this compound will be 4-bromo 2-methyl cyclohexane carboxylic acid. Okay, 4-bromo because B comes first before M. Okay, to put it in a single word, we must follow the alphabetically order. For a cyclic dicarboxylic acid compound, okay, it means that we have two carboxyl group attached to the cyclic compound. The name will be 1 for the first carboxyl group that is attached to the cyclic compound, and then X is for the position of the next carboxyl group. Okay, cycloalkane dicarboxylic acid. Okay, for example, for the first structure, we only have the carboxyl group. Okay, so since there is no other substituent, so this one can become our first carbon, this one also can become our first carbon. So let's say I'll number it like this. Okay, 3, 4, 5, and 6. Okay, so the IUPAC name for this compound will be 1,2-cyclohexane dicarboxylic acid, because the position of our carboxyl group is on the first and second carbon. We have two carboxyl group, use the prefix di. While for this structure, okay, we have two carboxyl group. Okay, so this one can become our first carbon, this one also can become our first carbon, but since we have another substituent here, we need to make sure that this chlorine, okay, so this chlorine atom will be placed on the lowest carbon as well. So the numbering will be 1, 2, 3, 4, 5, and 6. Okay, so we cannot place the first number on this carbon, because if we do it like we number it like that, okay, the chlorine will fall on the fifth carbon. So 4 and 5, okay, 4 is the lowest number, so that's why we number it like this. Then the IUPAC name for this compound is 4-chloro-1,2-cyclohexane dicarboxylic acid. When a compound contains a carboxyl group and other functional group, the priority is always given to the carboxylic acid as the parent name. Okay, so remember in chapter 6, we already introduced the list of the priority. Okay, so the carboxylic acid has the highest priority, so that's why if we have a carboxyl group and other functional group, it will become the parent name. So in this compound, okay, so this carbon will become our first carbon, second, third, fourth, fifth, and sixth. Okay, so the IUPAC name for this compound will be 3-methyl, because we have a methyl group attached on the third carbon, 2-cyclohexene, okay, because we have a carbon-carbon double bond between the carbon number 2 and carbon number 3, carboxylic acid.